Last class I've talked about first law of thermodynamics for open system. Today I had derived the equation also for open system. Now today I'm going to do a problem based on that equation. Now I give you the values of the mass rate at 83.3 kg per second, enthalpy entering, leaving, velocity entering, leaving, then height 5 meters, 1 meter, G is 9.8, Q heat loss is 16, 60, 80, 10 power 3. What's work? What is the work done? This is the question. No, the problem is G is in 9.8 meters per second square, okay, and heat is in joules, and everything is Newton meter. Therefore, you have to convert everything into joules, okay, per second. Everything should be in joules per second or joules per kg. So substitute all these values in the equation, okay, and you'll get work as 726 kilojoules. The answer we get, this answer WS will be 726 into 10 power 3 joules per second. You can check this answer by working out. Just your substitute for H1, H2, U1, U2, Z1, Z2, G, Q. So everything is given, you just substitute these values. This is 2777 into 10 power 3 joules per kg. 2252 10 power 3 joules per second. And this is also in second, 83.3. If suppose if it's in minutes, you convert it to second. So your mass rate is 83.3 kg per second. If you calculate, answer will be 726 into 10 power 3 joules per second. Okay. Now with this understanding, I'll take up the next topic on the second law of thermodynamics. Second law of thermodynamics. Now, the first law talks about energy conservation. What happens? Energy can be transformed from one form to another. Mass can be transformed. Entering mass is equal to exit mass. Constant law of conservation of mass, law of conservation of energy. But the first law doesn't talk about the direction of a process. For example, will A plus B give C plus D, or D plus C give A plus B? We don't know. So the direction of a process. In which direction? Heat will flow from high temperature to low temperature. Will fluid flow from high pressure to low pressure. All this is not answered by first law. Second law talks about the feasibility of a process. Feasibility. Feasibility means is it possible? And direction. Direction of the process. So second law says in which is it possible? If it is possible, in what direction it will go? Okay, will the heat go from high temperature to low temperature? Will gas go from high pressure to low pressure? All this will be answered by second law of thermodynamics. So first law talks about conservation of energy. Okay, if energy conservation is possible, in which direction it will go? Will answer by second law. I'll give you a few examples. For example, now I got two examples. One is a high pressure cylinder connected to a low pressure cylinder by a valve. In another case, I got two slabs. One is hot slab, another is cold slab. T1 is greater than T2. Now, suppose I open this valve, what happens? Automatically gas will go from P1 to P2. Till what time? Till P1 equal to P2. That is, gas flows automatically or spontaneously from 1 to 2. No one can stop it by nature. So by spontaneously, gas flow from here to here till P1 equal to P2. Similarly, high temperature, low temperature. Heat will automatically flow from T1 to T2. You can't stop it. It's a spontaneous process. Till what time? Till T1 equal to T2. In other words, this mechanical process proceeds till equilibrium. What is equilibrium? P1 equal to P2. Similarly, this will go on till T1 equal to terminal equilibrium. This is mechanical equilibrium, pressure equilibrium. Now, the second law says that, crude form of second law says that all spontaneous process proceed towards equilibrium. All spontaneous process proceeds towards equilibrium. Okay, it goes from high pressure to low pressure automatically. Similarly, high temperature, low temperature automatically. It's a spontaneous flow. all spontaneous process proceeds towards equilibrium. And second statement is, all spontaneous processes are irreversible. All spontaneous process are irreversible. Irreversible means it can't come back. P1 equal to P2, but it can't come back. So what you do is, if you want once you're going to get back this pressure, you add a compressor here, then send it back here. Then you can get. So you can't reverse the spontaneous process without external help. Here external help is a compressor. Similarly here, T1 equal to T2. Suppose I want bring this back to temperature T1, I will have a heat pump. Your refrigerator, air conditioner is heat pump. So I want to take this back to this temperature, I must have heat pump. So all spontaneous process requires external aid to come back to the original position. Therefore, two statements are, all spontaneous processes proceed towards equilibrium, all spontaneous are irreversible. These are the two crude forms of the statement of first law. Now, they have got what's called as infinite source and infinite sink. Infinite source and infinite sink. Suppose, what's the infinite source? Suppose I have a boiler here. Boiler. Its capacity is say 10 tons per hour steam production. Now from this boiler, if I take say 5 kg per hour of steam, will the temperature of the boiler change? It's not going to change because the amount of heat extracted is very, very small. Steam. So 10 ton per hour is the capacity, whereas I am doing only 5 kg per hour. So this temperature is not going to change. In that case, if its temperature is not changing, it's called an infinite source. An infinite source is one whose temperature will not change when heat is withdrawn from it. Similarly, infinite sink. For example, our atmosphere is infinite sink. You put heat, its temperature is not going to change. So any system or surroundings whose temperature does not change by drawing heat or discharging heat is called infinite source and infinite sink. Now let's take an example. Before that, I'll try to talk about entropy. The symbol is S, okay, and the units are kilojoules per kg degree Kelvin. Mind you, this looks similar to heat capacity. It's also kilojoules per kg, but Kelvin degree. Okay, what's the difference? This is Kelvin degree. So heat required to raise 1 kg through 1 degree from 21 to 22 or 22 to 23. So change in temperature here. Whereas the entropy is absolute temperature, kilojoules per kg per degree Kelvin. So different degree Kelvin and Kelvin degree. Kelvin degree means change in temperature. Okay. So entropy is kilojoules per kg per degree Kelvin. How to explain entropy? We know P that dW is equal to P dV. This is for a mechanical process. Similarly, for heat transfer process, thermal process, we got dQ equal to TdS. See, what this is work, pressure, volume. Your heat, temperature, entropy. By comparing these two equations, we can say what volume, specific volume is for a mechanical process, entropy is for a thermal process. So that's how you can easily explain it, that entropy is for a thermal process, whereas specific volume is for a mechanical process. That is one simple way of explaining entropy. Now, so this is the expression for dQ equal to TdS. Okay, or I can write ds as equal to dQ by T. Now, suppose one first example. Suppose temperature is constant, isothermal process. Then I can integrate this and write as delta S is equal to Q by T. And second is isobaric process. That is delta S is equal to dQ is what? mCp dt. Okay. Integrate mCp, I'll take outside, dt by T, T1 to T2. So if you integrate it, you get mCp log T2 by T1. Okay. Third is adiabatic process. Reversible adiabatic process means there is no heat loss or heat gain. That means adiabatic. dQ is 0 or delta S is equal to 0. So there's no entropy change, it's an adiabatic process. So isothermal process, temperature is constant Q by T. For isobaric process, mCp log T2 by T1, and for adiabatic process, reversible adiabatic process, delta S is equal to 0. Now, let's come back to our room. Suppose I got infinite source at temperature T, source, infinite source. And I got infinite sink at temperature T minus delta T. Heat is flowing from here to here, Q. Mind you, it's infinite source and infinite sink. That means by removing heat, this temperature is not going to change, this temperature is not going to change. So I'll call this source, this is sink. So what's delta S of source? Is isothermal process, okay? Therefore source is losing heat, it is minus Q by T. Whereas delta S of sink, if you say, it will be heat, it is gaining heat plus Q by what T minus delta T. Only if there are then different temperature, heat will flow. So heat flows from here. So total entropy is delta S of source plus delta S of sink. That is minus Q by T plus Q by T minus delta T. Okay. Now look at these two parameters. This is larger than this. There was a small break. Okay. Now delta S total is equal to minus Q by T plus Q by T minus delta T. This quantity is bigger than this. Therefore, it will be greater than 0. If this quantity delta T is 0, then this will be 0. Therefore, total entropy change can be either be equal to 0 or greater than 0. Any process where total entropy change is less than 0 is not possible. Therefore, the criteria for any process is that the total entropy change should be equal to 0 or greater than 0. Any process which total entropy change is negative is not possible. Therefore, all processes will proceed in a direction wherein the total entropy change is greater than 0 or equal to 0. A process with a negative total entropy cannot take place. So, this gives you the direction of the process. Okay. With this, we will stop today and continue later.